Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to look at how we solve equations involving complex numbers. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So, we are going to look at how we solve equations involving complex numbers by using the method of comparing the real parts and the imaginary parts. So let's start off by looking at number one. Number one requires us to find the square roots of the following, whereby for a we have minus 5 plus 12i. So if we assume that z squared is equal to minus 5 plus 12i, such that we solve for the square roots of this complex number, right? And we say let z be x plus yi, like this, right? This will imply that x plus yi squared should be equal to minus 5 plus 12i, right? Then x squared plus 2xyi, this will be y squared plus y squared I squared should give us minus 5 plus 12i, and then this will be, because we know I squared is equal to minus 1, so we know that this will be minus y, right, plus 2xyi to give us minus 5 plus 12i, right? So now we shall compare the real parts, right? This x squared minus y squared is equal to minus 5. This is equation 1. Then this 2xy is equal to 12, which is 2. So if we divide both sides by 2x, y is equal to 12 over 2x, which is 6 over x. And this is, this is equation 2. So we now have y is equal to 6x. So we can say in place of y we put 6 over x. Sorry, it's 6 over x, not 6x. So we're saying x squared minus 6 over x squared should give us minus 5. Right? So we're now solving for x. Then you've got x squared minus 36 over x squared is equal to minus 5. And then multiplying both sides by x squared, x to the power 4 minus 36 is equal to minus 5 x squared. If you collect this minus 5x squared to the left hand side, this will be x to the power 4 plus 5x squared minus 36 to give us a 0, right? And then we shall say let x squared be a, such that we've got a squared plus 5a minus 36 is equal to 0. And if we factorize here, we've got a plus 9 times a minus 4 is equal to 0, which implies that a is equal to minus 9 or 4, right? So this means x squared is equal to minus 9 or x squared is equal to 4, right? But from this, we need x to be the real part of our complex number. So x cannot take a negative value. So we discard this, which means that x is equal to plus or minus 2, right? X being the root of 4, so x is plus or minus 2, right? Such that y is equal to 6 over 2, or 6 over minus 2, right, which is, let me just rather write 6 over plus or minus 2, which will give us plus or minus 3, right? So we've got 2 plus 3i, right, or 2 minus 2 minus 3i. So these are the two square roots of minus 5 plus 12i. And now I would like to look at part B, right? Okay, so part B is basically the same thing, same application. right? Part B, we've got 21 plus 20i. So we're saying z squared is equal to 21 plus 20i. And we're saying let z be, now this time around, let's say a plus bi, such that a plus bi squared is equal to 21 plus 20i. Then a squared plus 2abi minus b squared is equal to 21 plus 20i. Then equating the real part, we're saying a squared minus b squared is equal to 21. And then we say this is equation 1. Equation 2 would be 2ab being equal to 20, right? Then if we divide both sides by 2a, b would be equal to 10 over a. So from equation 1, in place of b, we're putting 10 over a, such that we've got a squared minus 10 over a squared to give us 21. And this will imply that a squared minus 100 over a squared is equal to 21. Right, if they multiply both sides by a squared, we've got a to the power 4 minus 100 to give us 21a. Right, and then if we take 21a to the left hand side, we shall have a to the power 4 minus 21a minus 100 to give us 0. Right, then here we say let a squared be, say, m, right, such that m squared minus 21m minus 100 is equal to 0. And then now if we solve, here we've got 21 and 4. So 25 minus 25 and 4. So this will be m minus 25 and m plus 4 to give us 0, which implies that m is equal to 25 or minus 4. Right. So a squared is equal to 25 or minus 4, but we need a to be real. Right, so if a has to be a real number, we shall discard this negative, such that a is plus or minus 5. Right, then b would be 10 over plus or minus 5, which will give us plus or minus 2. So therefore, the two complex numbers that we need, the two square roots that we're looking for, plus or minus 5 plus or minus 2i, like this. Yes, so we've got 5 plus 2i or minus 5 minus 2i. Right, these are the two complex numbers that we need for 1b. And now let's move on to look at number 2. Okay, so for number 2, we've got, say, solve the equation z plus 2 complex conjugate of z to give us 15 over 2 plus I. So if we say let z be x plus yi, then you're saying x plus yi is equal to 2 times x minus yi to give us 15 over 2 plus I. Right, and of course, this is a plus here. Then of course, if we multiply both sides by 2 plus I, we're saying that 2 plus I is multiply x plus yi plus 2x minus 2yi to give us 15. Right, then 2 plus I, right, okay, so thus we get 3x minus yi to give us 15, right? So of course we can multiply throughout and throughout everything, but it would be also convenient to carry out this division by multiplying. So 15 over 2 plus I, we multiply by the complex conjugate of the denominator, we get a 15 times 2 minus I over, this is 4 plus 1, which will give us a 5. And then 5 into 15, this will be 3, 2 minus I. So I would rather leave it this side, right, over 2 plus I, then say 3x minus iy is equal to this, which is 6 minus 3i. So now if we equate the real parts, we are saying 3x is equal to 6, right, such that x is equal to 2. Then the imaginary parts, minus y is equal to minus 3, which implies that y is equal to 3. So therefore z is equal to 2 plus 3i, and then its complex conjugate is 2 minus 3i. Right, so these are the two solutions that we get for number 2. And now let's move on to look at number 3, which is the last question. Right. So for number 3 says solve the equation 4 plus 5iz minus 1 plus I C star to give us 15 plus zi. Sorry, 15 plus 7i. Right. So if we say let z be x plus yi, right, this implies that we're saying 4 plus 5i times x plus iy minus 1 plus I times x minus yi to give us 15 plus 7i, right? And of course, now we shall expand this and that, right? So we're saying 4x plus 4yi plus 5xi and then minus 5y minus x, right? This minus, and then this minus yi minus yi, which will give us a plus yi, then this what? Xi, so minus xi, and then I times minus yi, we get a minus yi squared, which is y, and then the minus there, minus y, to give us 15 plus 7i. Right, so if you collect like terms, right, if you say 4x minus x, you get 3x, and then if we say 5xi minus xi, we get a plus 4xi, and then if we say minus 5y minus y, we get minus 6y, and then plus 4yi plus yi, we get a plus 5yi to give us 15 plus 7i. And now if we equate the real parts, we've got 3x, right? If we actually group them first, right, 3x minus 6y, then plus 4x plus 5y to give us 15 plus 7i. So 3x minus 6y is equal to 15. This is equation 1, and then 4x plus 5y is equal to 7. This is equation 2, right? So here if we solve, say we're going to solve by elimination, multiply this by 4, then this by 3, right? We shall say 12x minus 24y is equal to 60, and then 12x plus 15y is equal to 21, right? And then if we subtract, this is equation 3, and that's equation 4. So equation 3 minus equation 4, that's 0. Minus 24 minus 50, that will give us minus 39y, right? Which is 60 minus 21, that's 39. So y is equal to minus 1, which implies that 3x minus 6 minus 1, that's plus 6, should give us 15. Then 3x is equal to 9, and x is equal to 3, right? Such that z is equal to 3 minus I, and then its complex conjugate will be 3 plus I, right? So this is how we solve for z, right? 3 minus I. Okay, so this was looking at solving equations that involve complex numbers. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.